All right, we are back. This is video number 2. We have taken the FSA files, converted them to text files, combined the first 2 columns of each into a combined Excel file, saved it as a text file. Now we're opening it in ShapeFinder. Great. So here's a quick intro on what the bottom bar here does in ShapeFinder. Okay, here's my mouse. So these display options, split channels, they're split right now, 1 through 4. We don't want to split any, so split none, apply. Boom, they're all at the bottom. You can scroll left and right, and there is our data. That's what it looks like. This is a 726 primer, so this peak over here is the start of the reverse transcription, so the ribozyme, I think. And this is unprocessed data. So basically this position here is like 700 something, depends how good the read was, and all of this data probably back to about 3,000 data points. Then it gets a little hairy. This is not good data, but you can see that it reads pretty much all the way. That's probably the end of our molecule. Anyways, so these display options, that's great. Channel attributes, all 8 channels are displayed right now. You can unclick them, and that'll only display a few. Apply that, see. So you'll be using this when we do the cubic constants. Excellent. Okay, one view, you can change the scale pretty drastically over here. Set the window to 200%. The view to one view, you could split it. Yours might look like this. That's okay. Don't panic. That can be easily fixed. One view. Excellent. Okay. We're at 200%. We're displaying all of them. Okay, perfect. First step, fitted baseline adjust. The great thing is you don't have to change anything. Apply to all of them. The window width is 200. Now watch, I'm going to click append, but you need to watch these electropherograms because they're going to be shifted down. Okay? It's like everything's just going to be it's like, hey, take a seat. Boom. They all sat down. Okay. So we did that. Now we're going to do a cubic mobility shift. Select cubic mobility shift. Pause. Now we're going to need to open up a Word document, folks. Blank document. Excellent. We're going to title it Cubic Constants. Okay? And we're going to need to save this in the folder we've been working in. Okay? This is sample, GA726. Save. Perfect. So the first alignment is going to be channel 3 to channel 1. So 3 to 1. You're going to have 4 numbers. Boom, boom, boom. Then we're going to do 5 to 1. Boom, boom, boom. And then 7 to 1. Okay. You'll fill this out as we go along. Command S. Save this. Pause here in Word. Back to ShapeFinder. Okay. So the first cubic mobility shift we're going to do is for channels 3 to 1. Okay, so we're only going to display those. Apply. Boom. Okay, so now we only have blue and black electropherograms. Blue is channel 1, black is channel 3. Now we go to the tool inspector and we're going to do a new cubic mobility shift. Create by sliding traces. Okay, hit OK. Boom. Now we're going to click, what channel do you want to slide? Well, we want to align channel 3 to channel 1. So we're going to click on channel 3. Now we're not going to click anywhere else in here until we're done. So now we're going to go into this viewing window and we're going to try to take the black channel of channel 3 and align it to the blue channel. So when you click in this screen, you click and drag. See, it's only highlighted a certain piece of the electropherogram. This is going to take a little bit of time to get used to, but this is how you align it. So see this, that's a good alignment. So I'm going to stop, lift up, and it goes back. Don't panic. this is what it's supposed to do. So what you just did is you align part of that electropherogram to the blue electropherogram, and that's ultimately going to influence the polynomial equation that this algorithm has, all the math behind it, and those are the constants that we're going to record. So each time that we do this, there's little data files that are generated. In the background, we don't need to worry about them. The program takes all care of it. Okay, but the most important part of this analysis step in the cubic mobility shift is that you want to have the most click and drags as possible. And so I just did this little region. Now I'm going to move here, and I'm going to get a little bit further down the electropherogram. I'm going to scroll, and I'm going to keep doing that. And just keep doing that. I'm going to keep recording this entire time while I do this. You can speed it up as much as you want. You can slow it down, but this will give you an idea of how long it takes. It doesn't take too long, and you should do it along with me. I'm not moving super fast. I'm just, scrolling a little bit, clicking in the same spot of the screen, and just dragging and aligning similar shapes. Okay, this is just trying to find patterns of peaks and align it. Okay, now everyone stop and look up at the video. Right now these peaks are really small, and you're like, well, hey Quinn, I don't want to strain my eyes. And I'm like, I have a solution for you. So you take this scale and you jack it up. Okay, now all of these peaks just got bigger. That's okay to do. It doesn't influence the data in any way. It just displays it a different way so you can align it better. So these peaks just got bigger, making it easier for us to notice patterns. And we can keep doing our job all the way through. We're at 2100 data points right now. That's perfectly fine, the progress that's going on. Guys, this ShapeFinder analysis may look scary and overwhelming, but once you do it a lot, or if you have a nice video like this to reference, it is going to be cake, and we are going to process a ton of data. So this is all going to be good. We haven't even gotten to the fun part yet. This is just kind of the drag of doing it, but that's okay. So this is all great data. I mean, there's sharp peaks. It's pretty distinct. There's not really any hills. Now we're starting to get in the hills, which is normal. Every time I've done this, right around 3,000 data points, it starts to look like this, where it's gone from sharp peaks, and now they're kind of hilly, right? And we can make them sharper if we just crank it up. And that's okay to do for this analysis step, this shifting step, which is fine. So we're going to crank it up if you haven't cranked up the scale, make it easier on yourself. All of this is still, good data. So we're going to want to align this. Now it's starting to get a little bit hairy. Like, now the shape is not uniform from what we have been seeing. And that's okay. That's just the nature of the beast. So you're going to do it as much as you can. And see, look at these. Wow, I don't even look at 4,300 here. If you want to pause and look up, this is like aligned. I don't even need to do much. So I'm just going to click and release. And so that registers in the program that, like, hey, this is a good alignment. So keep it here. Don't move this part. So that's all good. And honestly, quite frankly, once you get into these regions, you can stop. Because we don't care about this data. This is not going to be good data anyways, past this point. So we are done with the first alignment. So now, or the first cubic mobility shift, I should say. So we go back into the tool inspector up here, and we're going to hit done, okay? Now, mobility shift parameters, right? This little radio button, 1 through 8, those are for the channels. So we just did a cubic mobility shift on channel 3, okay? So we click channel 3, and holy cow, there are our values. We haven't applied this shift yet, okay? So what we're going to do is we're going to scroll for the excitement of the viewers. we are going to go back to where the good data is, right around 1900 to 2000, and it's ready to go. So like if we want to apply this, we hit append, okay? And once I do this, the black is going to move to the blue and it's going to look uniform. So here I go. Okay, so this cubic mobility shift, I would say, is average. It's very okay. You can play with the scale a bunch, but like no matter how much you play with the scale, it's okay. The peaks are generally pretty close. The alignment is okay. You want to confirm visually that this is a good, a good shift, and it is. I mean, they're more aligned than they were, and for our sakes, we can continue. You could try and be nitpicky and try and get them like right on top of each other, but the program will process this and align these peaks as normal, so that's okay. So now we're going to go up to the constants window, A, B, C, and D. See this polynomial equation I was talking about? That's where these constants come from. So we're going to Command C, copy this, go to Word, right under 3 to 1, and copy them in the order that they're listed. Okay, so A, B, C, D. Oops, sorry. Go back and do C. C and D. Excellent. Okay. All right. So we've recorded that. Let's save this Word file back into ShapeFinder. So channel 3 to channel 1 is good. Our research design actually has a bunch of internal controls. So the alignment of channel 3 to channel 1 will actually influence the alignment of channel 4 to channel 2. So we'll apply this view, and now these are different. This is different data. This is channel 4 and channel 2, and we need to apply a new cubic mobility shift. Okay, so what we'll do here is we'll hit this new button right up here, hit new, and this time we're not going to sliding traces. Okay, we're not going to align them like that. We're going to enter the equation by hand. Okay. Most importantly here, we're not on channel 3, we're aligning channel 4 to channel 2. And what numbers are we going to use here? You can edit this. You can type, my name in here if you want. We are going to use these numbers. Okay. Here's the thing about Word. When you copy this, see at the end of this, like to the right of their 4, there's a little space. Well, that's a new line character. It's not going to show up, but it will in ShapeFinder. That's just how the software is designed. Okay, so I'm on A. We copied it from Word. I'm going to hit Command V. Okay, it pasted. We got the little notification up at the top and edit. I'm going to show you a magical trick here. Hit delete and it'll appear because you just deleted the new line character. You're like, well, Quinn, that's not the most luxurious way of doing it. And my response is, I know, but it's functional. So, and it's easy to do. You just have to copy the entire line, highlight, delete, paste, delete the new line, and the whole entire constant value appears. So that's good. So we'll do that for all 4 values. I'm running up on my time here. Good. So we're done here with channel 4. It's done. We're going to append. And look, it's shifted. It's aligned pretty good. So we'll stop here and move on to the next channels in the following video.